So, welcome to tutorial number 1 on how to install and set up P2PRC. So the first thing is we need a terminal open. The next one is to just head to the P2PRC open source repository project. So this tutorial is to set it up from scratch. To compile it, build it, and run it. So you can just copy the link. I'm going to go to my documents folder right here. I'm going to make the, do I have P2PRC as a folder? I'm going to say make the tutorial. Oops. P2PRC. Now I'm going to actually enter the thing right there. So now I'm inside the tutorials folder, and I'm going to clone the P2PRC repository. So while it's cloning, we have a few dependencies to think about. Dependency number 1. We need the Go compiler installed. So if I quickly open another terminal right here, you need a Go compiler, and you can do Go version for that. And if you want to figure out how to install the Go compiler, so if you go to the Go website, Go compiler, doesn't matter sorry about the spelling, but you can go to this Go website here, and if I go to, let's see, download. So yep, so here you can use Snap if you're in Ubuntu, a Mac, but in the Mac it's literally almost just a double, like I think a really simple installation. I really forgot how I installed it in my MacBook, but it should be super trivial to install Golang. The dependency number 2 is a Docker container. So this one. Let me start Docker here. You can just again go to the Docker website to download the Docker container and have it set up. So while that's starting, let's get back to our terminal. So third dependency is we need Ansibles to install Ansible. So I'm assuming Ansible, I'm not sure how widely it's used, but at least for now we use Ansible as a way to deploy and automate running tasks on the peer-to-peer network. And all Ansible is, to do this, I can actually show an example of what I wrote before, an Ansible for P2PRC. And I think today we can try to run it. So if I think VS Code, I type VS Code here. There we are. Over here, we do have a simple, this is an Ansible file right here. This is just a set of declarative instructions to set up something, and you can basically run this over an SSH port, over SSH to set up some sort of dependency. That could be this code sample here, setting up VS Code. That could be to set up even something as CUDA or some fancy toolkit, or just it's basically setting up libraries. But I think over the future turn, I would really want to support something like Nix, because that's more convenient. But either way, so if I do docker ps here, we have that set up. And I think for Ansible, I'm not too sure what the command was. Was that the command line? Yep. So if you just set the command Ansible, and you can do something like brew install Ansible, I think, something like that. But I'm going to cancel it because I'm assuming I already have it installed. But anyway, you can go, fundamental Googling should do the trick. So now we have P2PRC cloned here. Let's go inside the repository here. So if you have Ansible installed, if you have Docker installed, and if you have the Go compiler installed, the next thing, all you have to do is to type, so if you are on a Linux or a Mac machine, you type make, or if you're on a Windows machine, you just literally run this little bat script, this installation of bat script. But since I'm on a MacBook, I'm going to run make. And what I would do right now is copy these two paths, and you would technically add them to the bash rc file, but I'm going to do this right here and paste them here, and I'm going to do P2PRC-h. And I would hope that it seems to have been successfully compiled. If we do P2PRC -ls to prove, yes, we do have. So either way, when we ran the make command, we compiled it. We compiled it, and now what we have done is when we ran these two export commands right here, so both these export commands the first one is we are basically pointing the variable P2PRC to our paths here, and the second one we are doing is just for the command P2PRC, we are pointing it to the binary itself in the second path. But the reason we're doing this is if you now go to the config file, you have the set of parameters or the set of configurations set by default. You can change the server port, for example, but here as you can see right here, we are using the default paths for running a container, for maybe running some plugins or storing some plugins, and so forth. And this is all set up automatically by just using the command make. But so we have installed a P2PRC network. Now, how do we run this network and broadcast our availability out there? So, really simple command, P2PRC dash. Before that, I'm going to copy these two commands right here. I'm going to open a new terminal, or do I have an existing terminal open? I have one here. I'm going to run that here as well. So if I do P2PRC dash hash, I have two terminals for P2PRC. So here, I've done that. I'm going to run P2PRC dash S. And just like that, my node is completely out of NAT. And I've broadcasted my node's availability, and I can actually access it from anywhere. And all I had to do was that. Now if I do P2PRC dash dash ls, you can see we're using because we only currently knew about this root node. We are using this turn server, and we're broadcasting our availability through this port right here. So if I had to do P2PRC dash dash specs, I can copy paste this right there, and the port here 52 is this one. Whoops. This port right here. And if I press enter, you can see I broadcasted the spec of my machine. And anybody running P2PRC as a client or a server can run this one command. And if my server is up and running, you can see my server itself. And right now, I think our network is small. I only have 2 nodes. So if I do ls, you can only see 2 nodes in the network. But I could eventually add even a 3rd laptop, and it will be available on this list. And I can find out its spec. And as you can see right here, to escape NAT, we're using an implementation called FRP, and it's a really nice GitHub project. If I would do Golang, so this is a reverse proxy I used, and which we use inside P2PRC. And in one of the tutorial series, we'll talk about how you can actually you can use P2PRC as some sort of bare metal implementation where you can actually write 5-line Go code so you can build your Go program, and you can also paste this 5 lines of code, and then you can basically use the same net traversal what FRP uses, and then you can basically broadcast, or you can make sure that when you're running a server on your local machine, like something like what ngrok does, you can actually, anybody from the outside world can access your server. And yep, but the funny joke is, you can see I've used it multiple times. That's because of that, because we use it in P2PRC, and so what I've done basically is we're using exactly most of the implementation of FRP, but rather than templating their configuration files like these, I managed to look into their source code and find out exactly what functions they were calling internally, and we've built up this nice sugary function, which is a lot more easier and a bit more automated, where for example, when you run a container, you can say spawn me 3 TCP ports, and it can look at the server. So for example, I want to basically run a container on my friend's machine, and I want to run, let's say, a VS Code server. I can run that on his machine and make sure it runs on ports available on his machine. and plus with the NAT traversal implementation, so it can do all these automatically under the hood. But enough of talking about things irrelevant to this video. But either way, so we have a peer running, we have our server running. How do we spin up a server? That is also really straightforward. So to make sure, first of all, make sure you have Docker running, and these are some servers of mine. I will just quickly delete them right now. But either way, what I can do is here, I'm going to do P2PRC --touch. I'm going to paste this IP address here. Oops, did not. Control C, Control V. I'm going to put this port because this is a port being exposed externally, and I'm going to say, let's spin up a server with, let's say, 3 TCP ports. Oh, right. I think I did a mistake here. Whoops. And now we're spinning up the server. We're allocating 3 TCP ports for the server. And I managed to break my code. Oh, wonderful. Wonders, wonders, wonders. Did I manage to break my code again? No such file. I wonder if I actually did manage to break my code. I'm going to say, so I think I managed to break something here. I do have, what is missing here? I think track containers are JSON. I can see that right there. It's an empty file. Sorry, I managed to break something, and I want to find out what did I break and how did I break it. Since we're already deep in this video, I am too lazy to retake this video again. No such file or directory called track containers. Why am I pointing to track containers? I think I can fix this. Let me fix this right away. So if you get this error, now you would know how to fix this. So here you can just go. So in my config file, it's being rather strange. I'm just going to do one small change here. There we are. Is there anything else which has been... I think there's one more place. So if you do get this error saying you can't find track containers, just go to the config file and remove just remove the track containers directory, because it's one directory below. I will patch this fix anyway by the time this video is released, and it should work more likely out of the box. But let's try to run this command again. Now let's see if it works. We're running it, and fingers crossed okay, now it works. Cool. So if I go to the Docker thing, I spawned 2. That was for the previous one. I'm just going to quickly remove this. That was due to our bug, but this is a container we've currently spawned. And if I do here in my terminal, P2PRC --tc track containers, you can see that we have spawned a container. This is our ID. And because this is a prototype network, of course, the password is password. So what I can do right now is I can SSH into this node. So I can do SSH master, because master is my username and my password is password. So master at we know our IP address, which is down here. So we copy this, which is our IP address. And for our port, so I'm going to put 102 here. For our port, as you can see here, we have addresses. These are some automatically allocated addresses. So we can run servers inside the container where internally we can map it to these ports if we're running some sort of TCP server. But what we can do right now is we can bcfetch. We have an external port automatically allocated on this node, which is our node. And if I do this right here and I click enter, I'm going to, so I see it's asking me to add a fingerprint. I will say yes. I'm going to put password as password. And as you can see right now, I am in my node and I'm inside my Docker container and I can run anything I would want. And this could be the same process to learn about your friend's machine and even spawn a container inside his machine. So since we're done that, and I can do, if I do again, P2PRC -tc, we have a container right here. So to prove that works, we can try something even more nicer. Let's try to run a plugin. To do that, I can just do P2PRC. If I do --vp, you can see we have no plugins in our thing because we haven't pulled one yet. So we have no plugin, so we can do P2PRC. I'm going to pull a plugin --pp. I'm going to go to my VS Code repository right here, and I'm going to pull this sample plugin, which I've written a while back. I'm just going to put maybe it wants me to put HTTPS. Cool. Now if I run the VP plugin, so you can see we have a VS Code plugin. We have the number of ports that it needs for the plugin and a bit of a description for that plugin. Now I can do P2PRC --. To run the plugin, it's going to be plugin, which I'll put this as the name because that's the name of the plugin. Whoops. --ID, and I'm going to use the ID of my container right here. And if I run that, so now I'm setting up the plugin on my Docker container in my machine, and of course this can be behind any network firewall. But as you can see, I think right here, yeah, it's spamming, my server is spammed with like, my turn server is basically spammed with traffic because we're setting up the container. But it's automatically setting up the container, which is good. Now it's pulling the code server. Let it run. By the time it's setting up, I should really consider charging my laptop. Cool, it's set up. Let me. Cool. So let me do P2PRC --tc. And here we have set up things with the container. What I'm going to do right now is, as you can see right here, we have isUse true. So I can copy my IP address, this one. I'm going to open a new terminal, tap here, that, and for my container I have so as you can see here, isUse is true, so it's automatically ran the VS Code plugin and it's set the VS Code server to run on the first TCP port allocated. If I run more servers, it'll automatically use the other remaining ports. There's going to be a future release where you don't even have to explicitly expose the number of ports you need, but that is coming. That will be probably available in the next release. So in that case, you don't have to worry about presetting the number of ports you need. But but either way, this is the one that's used. If I get 52554 and I run that, and it's not working. Why? Oh, whoops. I did a silly mistake. This is the one. Sorry, we have to make sure we have to use the description auto-generated port. And yeah, this will work fine. You can see we are loading the VS Code server. Cool. We have that. We can do stuff here. Anyway, we can access the Docker container, run things. And that's on how to set up a plugin. So that's a basic tutorial on how to set up the network, quickly broadcast it out. So for example, if you send anyone, this is using our Tone server. So this is actually a public IPv4 address. And this one, so what happens is when you send a request to the public IPv4 address with this port, it automatically sends it down to your node running in your house. So the only bottleneck with P2PRC currently is that you need some sort of node that's publicly available. So one setup I really like to do is to get this really cheap DigitalOcean instance for example, $4 a month, and keep that running to relay traffic, and then under the hood have as many servers as I want, and yeah, so, and then I have as many servers as I want, and I can basically use a Tone server to spawn containers of servers in my home network and run certain tasks in them. And what I could do later on is also have a CDN sort of, what you would say, yeah. I could have the CDN pool of, or I could have like multiple CDNs, so multiple cheap DigitalOcean servers in like different zones. And with P2PRC, we can automatically figure out when we're relaying traffic, we can relay through the closest node available. So you get the best, so I would say least amount of ping or least amount of latency in between two nodes. But that would be the setup tutorial.